So we should be on number 3 down here. And what we're asking you to do is to graph this equation. So we want you to sketch this by plotting the vertex and then 2 points on either side. The issue with this now, and this is what we're kind of building up to, this is not in what we call vertex form. This is not the one that you can just look at and right away determine what our vertex is going to be. So what we've been working on, so don't write down what I'm going to write down right now. I'm going to do a quick little refresher, and I want you to keep this space open for something that actually applies to number 3. What we've been working on is, let's say I gave you x squared plus 12x plus 7, and I've been asking you to put that into vertex form. So what we've been doing is I had you a bunch of times on Friday. We're splitting this up a little bit, and what I've been asking you to do is make a perfect square trinomial out of these first 2 terms. And what we've been doing is we've been divided that by a 2. That's 6. We would then square that to get 36. And then what we then talked about, how since we've added an extra 36 here and we have a 7, we would need to subtract 36 on the backside. And then this would give us x plus 6 squared. And then the 7 minus 36 gives us this negative 29. We did a bunch of those on Friday. Now, 5 days ago, so almost a full week ago. Hopefully that's somewhat familiar. But we did that. Every single one of those we've done up until this point, there's always been a 1 in front of the square term. If you look at this one, we now have a 2 in front of the square term. And every one that we're going to do today, tomorrow, the next couple of days, it's not going to be a 1 anymore. It's going to be something other than a 1. And that now makes this a little bit trickier. It makes it a little bit harder. Okay, but we're still going to be doing the same thing I just did, trying to make perfect squares, but we don't just have one of them. All right, so now I do want you to write down what I'm going to start with now. So when we see, if you remember this x squared, when we did those area models, so this you do want to write down. So if I went ahead and drew in a square, whenever we had that square term, that always meant we had an x here and an x here. Those multiplied together give you x squared. It still means that, but what's now different is, if you notice there's a 2 in front of this, what that's actually telling us is we have a second one of these guys, and we have another spot where it's an x and an x and an x squared. Hence the reason we have, 2 x squareds shown in this equation. All right, so we now have 2 x squared corners. From there, what we would then do, we'd go to the next term. This is 12x. And remember how the middle term was always split evenly between here and here? Well, we used to divide by 2 because we only had to fill in these 2 boxes with the 12x's that we have up here. But now that we have 2 boxes, we also have spots here and then here. So these 12x's now need to be split up evenly into 4 separate locations. So if I'm going to take 12 and split it evenly amongst 4 different locations, that should leave us with 3x now in both of these corners. If I added all those up, 3x plus 3x plus 3x plus 3x, it gives us the 12x that we're supposed to get. All right, we all agree with that? All right, what that then tells us is this x had gotten increased by 3 in order to get 3x, as did this one. This is the exact same thing. We get 3 plus 3 over here. So then that now tells us what we would now be getting in this lower right-hand corner box. So put in now what each one of these lower right-hand corners would have, just looking at our rectangles. All right, hopefully we then see, since this rectangle is this 3 and this 3, each of these would have a 9. So what we've now done is created 2 perfect squares. So I'm going to kind of write it as an equal sign right now. What we've done is created 2 perfect squares, and what we've created perfect squares of, notice here, x plus 3, and then we have another x plus 3, x plus 3. So we have 2, so we're going to square it, of these x plus 3 quantity squares. Do we follow that part of it now? Now, we're not done, because think about how many these constants add up to equal. So if I look at this guy and this guy, when I do this, this actually gives me 18 constants. If we go back up to our problem that we're currently trying to deal with and create, we don't want 18, we want 19. So if all I currently have is an 18 right now, and I need 19, wouldn't that mean that we need to tack on an extra 1 at the end of this? Okay, that then takes us from the 18 that this gives us, add the 1, we then have the exact same equation that we have right here. All right. What that now does, this is vertex form. So now if I ask you to give me the vertex, when you look at the original, you can't really do that. When we look at this one, we can. We should now be able to see that our vertex would be a -3, +1. So I'll write that below it. -3, +1 is our vertex. We can now go 1, 2, 3, and then up 1. So here's our vertex. This just says sketch. Don't worry too much about the points on each side. That takes a lot of time that I don't want to use right now. As long as you know this is a +2 and it opens upwards, then we can just draw a quick little sketch showing a parabola with a vertex at a -3, 1, and the parabola opening upwards. Okay. All right. If you're still not sure where exactly that came from, we're going to do another one here in a second, but we're going to continue to use this area model for the first couple, and then we eventually want to kind of get to the shortcut that we're using on Friday. Okay. So now go to this next one. So go to number 4A. And we're going to do a similar process. Let me get rid of my mouse. So we have our x squared. So if we drew our little area model in down here, we know we have an x here and an x here, and then an x squared right there. But the fact that there's a 2 in front of this means we actually have 2 of these area models that we want to draw in. And then we create another x squared rectangle there. So we know that's an x, and then that's an x. This middle term, so this -8x, when we did these, we're always getting split up between this corner and this corner. But now that we have 2 of these, it has to get split up evenly into 4 different boxes. So if we had a -8, and we're going to split that up evenly into 4 different boxes, we're really just doing a -8 divided by 4. That would give us a -2x in each of these guys. We can then fill in the outer edges. This means that this x got decreased by 2, so that's a -2. This would also have to be a -2. And then the other box is identical. We're just creating 2 identical perfect squares. And then with that, fill in, if we know that, that should allow us to now fill in this bottom right-hand corner in each. So fill that in, make sure we know where that's coming from. And then what we should get, if this is a -2 here and a -2 here, we're multiplying those together. This should be a 4 in the bottom right-hand corner for both of those boxes. Okay. All right, so now let's write what this should give us. What we have is an x minus 2 times an x minus a 2. So the way we write that is x minus 2. Instead of writing it 2 times, we just square it. X minus 2 times x minus 2 can just be written as one of them squared. But we have that 2 different times because we have 2 different rectangles with the exact same measurements of x minus 2's. And then now think about our constant, because this is kind of the rub now. This is what we have to put a little more thought into. What we currently have right now in our 2 perfect squares, we currently have 8 constants. We have 8 of them. We need 14. So if we currently have 8, we need 14. wouldn't that then imply that we need to tack on an extra 6 to our area model that we've created at the bottom? Okay. Now, remember the shortcut from Friday? Remember how we said whatever that number is right here, and in this case it's 8. Remember how we said we could really just go up here and subtract it away from the constant that was there? Wouldn't 14 minus 8 also give us our 6? So that shortcut would still work. I don't know if I did say that on the previous one, but it's the same thing up here. We had 18, so that's why we needed an extra 1. Or just take this 18, go up to the original constant, subtract away 18, and that would also be a way for us to get that 1. All right. I like showing that with the area model first, so we can draw a connection to what we have been doing for the last 2 weeks or so. Long term, especially when you go down to C, we would prefer to not draw out 4 of these. It becomes pretty tedious. So we want to kind of do this with a little bit more of a shortcut. So go back to number 3, and then we're now going to talk about the shortcut that we used on Friday a little bit. All right, so go back to 3, and then I left this space here so that we can do a little bit more work. Before we get into that work, I want to do a quick little review. We talked about this a little bit last week. Let's say I ask you for the greatest common factor, and I give you 6x squared. Let's do 12xy, and then 24x cubed. And I ask you for the greatest common factor. What that means is we're going to look to each number. So if I go to the 6, 12, and 24, we want the greatest number that goes evenly into both of those. So between a 6, a 12, and a 24, 6 would be the largest number that goes into both. This one has 2 x's, this one has 1, this one has 3. Since they have to be common to all 3, there's only 1 x that's common to all of them. And since this is the only guy with a y, we don't have a common y anywhere. So this is what we would call our greatest common factor. Okay. All right, one more. So just think this in your head. You can write it down if you want, but just think this one through. Let's say I gave you 16. Let's do 12 and 24. Give me what you think the greatest common factor of those 3 numbers would be. As a hint, it's not 2. We want the greatest common factor. 2 is a common factor, but we can go bigger than 2. All right. Okay, good. Some people saying it, putting their fingers up. Yeah, it should be 4. 4 is the biggest number that goes evenly into all of those. That's our greatest common factor for those numbers. Okay, so keep that in mind. That's going to be something we're going to deal with when we now go back and do this little shortcuts. All right, so now back to 3. Like I showed you at the beginning that we reviewed from Friday, here's what I want you to now do. Take the 2x squared and the 12x. What we're going to do is we're going to make a perfect square out of this. So if you remember on Friday, this is what we were doing. And then the 19 we're going to deal with at the end. Oh, it's my prime day here, apparently. What you're now going to do next, so this is now harder, right? And the reason this is harder is we don't have a 1 in front of this x squared. It's one of these jobs down here where we have multiples. So the way we're now going to do this, since we want to figure out what this is, we're going to turn this into a 1. We want the 2 to become a 1. And the way we're going to do that is by taking out, so let me erase this blue guy. So look at these 2 here, this 2 and the 12. Do what I just asked you to do and identify what the greatest common factor would be between the 2 and the 12. So the biggest number that goes into both a 2 and a 12, all right, should be 2. So what I'm going to have you do is we're basically going to pull that out of the parentheses since that's the greatest common factor between them. Now think about what's left over. If this first term had a 2 and an x squared and I just pulled out the 2, wouldn't the only thing left over be the x squared? Then I have my plus sign. This was a 12, but since I pulled a 2 out, the only thing that could be left over is a 6x. Because think about if you distribute. If I distribute, wouldn't the 2 multiplied by the 6 give us this 12 that we started with? All right. Now put your blank again. And what we've now done by pulling this 2 out, this is what we spent all day Friday doing, is completing the square by putting in this number. So I want you to do that real quick. Put in the number into this spot. That would now make the inside of the parentheses a perfect square. Hopefully pretty nice, because you actually have the squares below, correct? If you're looking at my screen, if you look at what you have written, here's one square, right? Don't we get a 9 down there? Isn't that what makes this a perfect square, is a positive 9? But notice how we had 2 of these, right? We don't just have this one square with a 9, we also have this other square with another 9. So don't we really have 2 times 9? 2 times 9 is 18. That's what we would then be subtracting away from the number on the back side. So even though it's 1 9, we have it twice. So we're not just adding a 9 here, we're adding an 18. Oops, and what that now allows us to say is we have this 2. This is now the x plus 3 2 different times. And when we now do the 19 minus the 18, that gives us the plus 1 that we also got down here. All right. If you're thinking right now, I'm not exactly sure what just happened, you're probably not alone. Okay, the first couple of these, it's going to take a minute. We're going to do a bunch of them here today and tomorrow. But that's how we want to do this now, so we don't want to have to draw all these rectangles all the time. All right, so now let's go to this next one. And the same thing, we're going to try to do this with a shortcut. See if this now makes a little more sense the second time around. We're basically just going to reproduce here, but without having to do all the areas. So here's what you're going to start with. You're going to say, let me make this bigger so I have room to work. Okay, that's a bad idea. Now it's frozen. Put it on here. All right, so take your f of x equals, and then we're going to do 2x squared minus 8x. And we want to know what are we going to put there. And then that extra 14 we're going to ignore for right now. So then what I want you to now do is the next step is to look at these two numbers and think about what your common factor is between that. Because what we want to turn the 2 into a 1, and we're going to do that by basically taking out the greatest common factor. So do we agree between a 2 and an 8? It's the 2. Yeah, so we want to take that 2. We're going to pull this out. The first term is only going to have an x squared left over. And then what you're now thinking is minus what? So 2 times what would give us that 8? And it would have to be a 4. So all I want you to now do is, like we did on Friday, make a perfect square trinomial on this. This we've actually been doing for a little while. So fill in that blank. We can now do that because we have a 1 in front of that x squared. It'll behave just like all the ones we've done up until this point. Wish I would have written smaller down here. All right, whether you're doing it in your head, you're doing it algebraically by dividing by 2 and then squaring it, or we've done it already, right? Aren't we completing these squares with 4s in the lower right-hand corner? So that's what we're adding. But notice how we have 2. We have 1 in this square. We have another 1 over here in this square. So what we really have is 8. The way we can get that when we don't have the areas to look at, just look at what we're left with. The 2 would be distributed to the 4. That's really an 8. That's what we then subtract on the back side of this. And when we do that, just like we did down here, isn't the 14 minus the 8 going to give us the 6 that we got when we did it with the area? So what we can now do is write our final answer, the 2, and then we have x minus 2 squared, and then now this gives us 6. The same exact thing we got using that area model. Okay. All right, don't panic yet. I'm hoping we'll do one more, and then I'll give you one that we'll see if you can kind of go through on your own. Okay, we're going to skip B for a minute. I don't want to jump to B. Go to letter C. So this guy. And again, the reason we would prefer not to do the areas all the time is just because, think about what this would mean. You would need to draw out 4 of them because you would now have 4 of those x squared terms, and we prefer not to do all that area drawing. So here's how we're going to do this without having the rectangles to look at. So do 4x squared plus 16x, and then we need to figure out how can I make a perfect square out of that, and then deal with the 7 at the end. So what we want to do is we want to take out this 4. So between a 4 and a 16, if I factor that 4 out, the only thing left over for this first term would be that x squared. The next term, if we had a 16, the thing that would be left over is if I did 4 that I have out in front times another 4x, the 4 times the 4x would give us the 16x. And then what we want to now know is what would make this a perfect square. So do that real quick. We can now do this, fill in this spot. All right, so without the area, you're just dividing this by 2. That's 2, and then you square that. We would have had 2 times 2. So hopefully we all added a 4 right here. Can we all get that? Now, what that means is that would have been the constant in one of these squares, but don't we have 4 of them? Because I had 4 in front. So if I really have 4 of these, so a 4 here, a 4 here, and a 4 here, isn't that really 16 constants? So it's that we need to subtract away on the back of that 7. Now, let's say I don't draw this. Now the area is a good thing to look at. It's a nice tool. Let's say, where do I get the 16 from if we don't draw all those out? Where we can get that 16 from is simply distributing, right? The 4 times this 4 is really a 16. That then would tell us that's what we need to subtract away from the 7 in the back. All right, so that our final answer has a 4 in front. What we had 4 of, notice how we have x squared plus 4x plus 4. That would have meant each square had an x plus 2 on each side. And we had 2 of those, minus 9. All right, any questions on that? Anything we need to explain in terms of where we're getting all this stuff from? Okay, if there are no questions, then what I want you to do, take a minute. If you can find a space on your paper, or if you have a blank piece of paper nearby, take a minute. I just want you to try this one. So this isn't on your paper. Just see if you can get through one of these. So I'll do 2x squared. I'll make the mistake I made last period. We'll do 16x. No, let's not do that. Let's do 12x plus 4. and see if you can put that into vertex form. If you need to draw the areas, you can, but see if you're understanding all these steps that we're going through, because it's not easy. There's definitely a number of things happening right now. Okay, let's see where we're at. Let's see if we're close. I'll draw the area at the end so you can kind of see how they're interrelated. But what we're just doing right now is we're trying to create two perfect squares out of these first two terms, because it's usually the constant that kind of screws things up. So we just ignore the constant. We deal with it at the end. What we've been asking you to do then is we want to make this a 1 so that we can do what we've been doing for the last week. So what we've been doing is, if I'm going to turn that into a 1, I'm just pulling out a 2 from each of these. So in that next step, if I pull out a 2, I should have x squared left over. And then you're just thinking, if I'm going to be distributing this 2, I would have to have a 6 right here, so that the 2 multiplied by the 6 would give us that 12. And then we're trying to figure out now, what could I add to make this a perfect square? So this now is our key. All right. So if we got to that point, you're dividing this by a 2. We would have then squared that. That gives us a 9. All right, did some of us get that, hopefully? Maybe. What that means, if we actually did all of this, that means each of these two squares has a 9 down here, and we had 2 of them. So this really is 18. We only want 4 in our problem that we're trying to rewrite. So the 18 we need to subtract away. The way we get the 18, if we don't want to look at the area, is the 2 that I pulled out multiplied by the 9 that makes it a perfect square. That's 18. That's what we're then subtracting away on the back. All right, so that our final answer, we'd have 2. And then the only way we're going to get this to be a 9, you would have had an x plus 3, x plus 3, x plus 3, x plus 3 is an x plus 3 squared. And then the 4 minus the 18 should give us a negative 14. Okay. If you got that, that's very good. For just the 3rd or 4th day of doing this, that should be good. If you didn't, don't freak out. We're pretty much doing this tomorrow. There's little tweaks and little changes as well. Hopefully by the end of the day tomorrow, then we're understanding it. And if not, then you want to make sure you get in to see me or Mr. Kublitz in like a second period. If you go back to our homework real quick, or the notes that we were doing, we'll do these tomorrow. We've got a little less than 4 minutes. The reason I skipped B and D is not only do we have a 3 in front of this, but notice how it's a negative. Very, very similar steps but the negative also now makes it a little bit trickier in terms of how we're going to be able to handle all of this. Okay, so we'll pick up from here tomorrow. We'll start with B, we'll do D, and then I'll give you the homework. We're actually do a number of these together tomorrow from the homework just to make sure hopefully we're up and running and have a decent shot at completing that without too much stress. Okay? All right. So what that then means is you don't have any homework tonight. We'll do these two tomorrow, and then we'll talk about what we would do for the homework once we get some of those done. All right? All right, so with that, we'll let you out here a couple minutes early. Just have this tomorrow, and we'll see you tomorrow. Okay?
Have a good day.
Okay, see you guys. Oh, I guess we could have done this, Mr. Kubowitz, in those last couple minutes. Forgot, I didn't see that.
Oh, I forgot about that part too.
Oh well, we'll do that tomorrow with one of them.
Yeah.
Let me record this.